Okay, let's take a look at these questions here. It says a car initially traveling at 15 meters per second north accelerates to 25 meters per second north in 4 seconds. The magnitude of the average acceleration is blank. So remember, first of all, right, magnitude. If you see the word magnitude, honestly, just replace that word with value. It's not going to change anything, right? Magnitude means value for our purposes. It's the size of a numerical quantity, right? So the magnitude of the velocity in this case, the initial velocity, is 15 meters per second. That's no different than me saying the value of the initial velocity is 15 meters per second. Same thing with the time, right? I could say the magnitude of the time is 4 seconds. Or I could just say the time is 4 seconds. It's the number that goes with it, the value of it. So let's write down when we know that. We know that we're initially traveling at 15 meters per second north. So that means my initial velocity is 15 meters per second. And I can write north. Now, how do I know it's my initial velocity? Well, first of all, it says we're initially traveling at 15 meters per second. So initial, obviously, initial velocity. The other part of that being the unit here, meters per second, right? Since it's meters per second, the only thing that's ever measured in meters per second is a velocity. So initial meters per second, 15. Initial velocity is 15 meters per second. So know your units. That's the number one thing here, right? If you don't know your units, you're not going to be able to solve these questions because you won't know what's what. You won't know how to show your work properly on these questions, and it's just going to make your life a lot easier if you do know them. So then it says that we accelerate to 25 meters per second north. Now, one thing I noticed when you guys were doing this question is that you put down the acceleration as 25 meters per second. Just because it says you accelerate to 25 meters per second doesn't mean that's the value of the acceleration. Right? Because first of all, we know acceleration is measured in meters per second squared, not meters per second. So that should be an immediate sign to you that that's not your acceleration. Read it very carefully. It doesn't say you accelerate with an acceleration of 25 meters per second squared or anything like that. You accelerate to a speed or to 25 meters per second. So if you're driving a car, right? Let's say you're going like 0 miles per hour. You're just sitting in a parking lot. Then you start accelerating up to a speed of 10 miles per hour. Well, it doesn't mean you accelerate at a rate of 10 miles per hour squared, right? You accelerate up to a speed. You go faster and you reach that speed. So our final velocity after we accelerate is 25 meters per second. And still north. Again, your other sign here is that it says 25 meters per second. Meters per second is always going to be a velocity. Then it says that we have a time, 4 seconds, right? 4.0 seconds. That one you should just know, right? Time is always seconds. You're not going to measure a distance in seconds. You're not going to say that that thing is 3 seconds. Well, I guess you could say something's like 3 seconds away from you, but you'd have to know the speed in that case. You wouldn't say you're 5 seconds tall. How about that, right? It's always going to be a measurement of time for seconds. So we know time, 4 seconds. The magnitude of the average acceleration is, we don't know. So always approach the questions like this. Pull out the information you know, make a list of that stuff, think about the thing you're looking for. Write it all out. If you don't write it out, it's going to be very easy to get lost, and you won't know what you're looking for, you won't know what you know. But if you keep a list of it, you keep track of what they're telling you, it makes it a lot easier. Because once you have that, now it's a matter of looking at your formulas. Right? If I look at my formulas, I'll write them out for us real quick. The ones that you're going to need to know, you need to know that acceleration is the change in velocity over time, delta V over T. Another way of saying that is VF equals VI plus AT. Also know D equals VIT plus 1/2 AT squared. Now, that doesn't mean you have to have that memorized, right? You don't have to have any of these memorized. They're all going to be given to you in your reference table. So don't feel like you have to memorize it. It's going to be a waste of time to memorize this stuff. VF squared equals VI squared plus 2AD. And lastly, know that the average velocity is the distance or displacement over time. Know those guys. Think about what we know now. In our example, we want acceleration. So first of all, you have to have acceleration in your formula if you want to solve for it. This one, acceleration is nowhere in there. How can I solve for it if it's not there? Can't be that one. Acceleration is in this one. Acceleration is in this one. Acceleration is in this one. One common mistake that students make is if they're trying to solve for acceleration, they'll pick the formula that says acceleration equals blank. Just because it says acceleration equals ... doesn't mean that's the only way to solve for acceleration. As long as acceleration makes an appearance somewhere in that formula, like right here or right here, you can use that formula to solve for it. So if we take a look at what we have VI, VF, T, and A. We need a formula that has all of the things that it doesn't have to have all the things that we know, but the formula we have to pick, the only thing in that formula that we can't know is acceleration. I have to know everything else in there. Let me give you an example. This formula is not going to work. I may know initial velocity, I may know time, I may know time again over here, and I want to find acceleration, but I also don't know displacement or distance, whatever the context of that question is. What comes up with that is then I don't know that, and I don't know that. Well, you can't use a formula if you don't know two things in there. It's not going to work. You have to know everything in there except for the one thing you want to find. So let's do that. VI equals VF. Actually, VI, we have VF, we have T and A. Well, if we look at this one, we know VF. We know VI. We want A, and we know T. Again, what I'm saying here is that if we want to pick that formula, we know everything in there except for the thing that we're looking for. So this is going to work out perfectly. There's only one unknown variable in there. And again, it's the thing that we want. So let's try out the math then. VF equals VI plus A times T. VF we know is 25 meters per second. Write your units. If you don't write the units, I'm not giving you full credit on it. It's just the way it is. VF, 25 meters per second. VI, 15 meters per second. Plus A times 4 seconds. What I'm doing here is I'm just taking all my numbers, plugging them right into where they appear in the formula. T is 4. A is A, because I don't know it. I have to leave it as A. VI is 15. VF is 25. Let's do the math now. Once you start doing the math, don't bother about the units. So I'm going to drop them, do a little bit of math. A times 4, that's 4A. You want to do the thing, you want to move the stuff around in such a way that you can get that variable by itself. Start with the things that are most removed from that variable. This 4 is attached to the A. So we're going to save that to the end. Let's move our 15 away. It's 15 plus 4A. So this guy is involved in addition. Well, let's do the opposite of that. Remember, inverse operations to move stuff around. You guys have been doing that hopefully since like 7th or 8th grade. 10 equals 4A. We want A alone. It's 4 times A. Remember, inverse operations, if it's 4 multiplied by A, you divide by 4 to get it alone. 10 divided by 4, that's 2.5. And don't forget your unit in that last part, right? You have to show your unit on the very last step when you write your final answer. Except this is a multiple choice one, so I guess technically you don't have to, but on my test, it's going to be all short answers, right? It's going to, well, maybe not all short answers, but it's going to be a lot of short answers, which means you have to show all of your work. Formula. Plug in the numbers with units. I don't care about this stuff. Final answer with units. So what I'm looking at is this. I'm looking at this, and I'm looking at this. This part, I don't really care about. You could write it, so I could see what you did. You should write it, again, so I could see what you did. But you're not graded on anything right here. You're graded on this, this, and this. But we have our final answer here, right? 2.5 meters per second squared. Let's take a look at another one. It says, what is the final speed of an object that starts from rest? Okay, good start, right? Good start. From rest. And accelerates uniformly at 4 meters per second squared over a distance of 8 meters. So I circled that word rest there. If you remember what rest means, think about you sleeping in bed. You're resting in bed. You're not moving, right? You're not going fast, you're not going slow, you're not moving at all. So at rest always means zero velocity. And it says that we start from rest. Starting means the initial, velocity. So velocity, VI, initial velocity, we're going to say is 0 meters per second. We want to know what the final speed is. It says right there in the beginning, what is the final speed? So that's what we're looking for, VF. We don't know what it is. We accelerate uniformly. Uniformly just means constantly at 4 meters per second squared. Again, know your units. Meters per second squared, that's a dead giveaway. This is an acceleration. And lastly, over a distance of 8 meters. Again, know your units, meters. That's distance or displacement. Okay, same idea. Let's look at our formulas. Pick the formula that has all the stuff that we have. I always say that kind of the wrong way. Pick the formula that has the stuff in such a way that the only thing we don't know in that formula is the thing that we're looking for. So in other words, we have to pick a formula in this case where we know all the variables in that formula except for final velocity. So let's take a look, right? I can't use this. Why? Because I don't know VF. I may know VI, I know A, but I don't know T. So I wouldn't know this, and I wouldn't know this. Again, can't pick a formula if you don't know two things in there. D equals VIT plus 1/2 AT squared. Well, I can't use that one either. Maybe pause it for a second and think, why can't I use that formula? If you paused it, I'm going to give the answer right now, right? The answer why you can't use that formula is because VF doesn't even appear in there. I can't solve for VF, it doesn't appear in the formula. This one, VF, okay, I want to find that, that's good. VI, I know that. A, I know that. And D, I know that. That's perfect. I know everything in that formula except for the one thing I'm looking for. So let's go ahead and reuse that formula. VF squared equals VI squared plus 2AD. Plug in our numbers. VF, I don't know it. Leave it as it is. VF squared stays as VF squared. VI, we know that's 0. Notice again how I put my units here, meters per second, and I'm squaring it. It's not meters per second squared, because that would be an acceleration. It's meters per second, and then that whole variable is squared. So it's meters per second in parentheses on the outside squared. Plus 4 meters per second squared, because it's an acceleration, times 8 meters. Okay, let's do the math. 2 times 4 times 8. In other words, 2 times 8 times D. Well, 2 times 4 is 8. 8 times 8 is 64. So this is 64 right here. 0 squared is 0. VF squared still over here. 0 plus 64, that's 64. So we have VF squared equals 64. And we don't care what VF squared is, right? I'm not asking what VF squared is. I'm not asking you what the final speed squared is. I'm asking what the final speed is. So take the square root to get rid of that square. Square root of VF squared is VF. And square root of 64 should be 8 meters per second. There you go. It's A. Let's do another one. Pitcher throws a fastball at 42 meters per second. If the batter is 18 meters from the pitcher, approximately how much time does it take for the ball to reach the batter? Well, if you're throwing a baseball, you're not going to be throwing it down, right? I'm not going to be throwing a baseball at the ground. That doesn't make any sense. I'm not throwing it up. Again, it doesn't make sense. You don't throw baseballs upward into the sky. You throw them straight. So sometimes you're going to have to do a little bit of thinking with these. This one, it says you throw a fastball. So you have to assume that you're throwing it straight. You're not throwing it up. You're not throwing it down. Which, if you're throwing it straight, well, there's no horizontal acceleration. Which means we know that our acceleration is 0. And we throw it at 42 meters per second. Initial velocity, therefore, is 42 meters per second. The batter is 18 meters from the pitcher. D is 18 meters. Approximately how much time does it take for the ball to reach the batter? T is what we're looking for. Again, pick your formula. Choose the one that has only one unknown variable, with that one unknown variable being T. Pause it. See if you can find the formula you want to use. Right? Here are your formulas. Which one do you want to use in this case? We know A, we know VI, we know D, and we want T. Okay, hopefully you picked. I feel like I'm doing like Dora the Explorer. I'll pause for you guys, and then you guys, take care of the other side on your end. So D equals VIT plus 1/2 AT squared is what you should have picked here. Why? Because I know D. I know VI. I want T. I know A. And I know T. The only thing in the formula I don't know is T, which means I have only one unknown variable here. Let's plug in our numbers. D is 18 meters. VI is 42 meters per second. T is T plus 1/2. A is 0 meters per second squared. And T squared is t squared. All right, well, let's do the math now. All of this, 1/2 times 0 times t squared, 0. Anything times 0 is 0. 42 times t, that's just 42t. And 18 carries down. So if we want to get t alone, well, we don't care about plus 0. I'm going to ignore that. Anything plus 0, why would you even bother with that? So I'm going to divide away my 42. And then we have 18 divided by 42, which, I mean, based on my options, I'm going to estimate 4.43, but I don't want to look like a fool, so I'm going to double check that that is correct. 18 divided by 42, and it is 0.428, which is 0.43. And that's that. Let's see the next one. In a race, a runner traveled 12 meters in 4 seconds as she accelerated uniformly from rest. The magnitude of the acceleration of the runner was blank. Runner traveled 12 meters. 12 meters, that's a distance. 4 seconds, that's a time. Accelerated uniformly just means that we accelerate at a constant rate. And we know that we're from rest. So if we start from rest, initial velocity is 0. Magnitude of the acceleration of the runner was blank. Remember, if you see magnitude, just think value. I get that question all the time. What does magnitude mean? Just value. How big is that acceleration? What number is that acceleration? So I'm looking for my acceleration. So I'll write a equals question mark. All right, same idea. Look at your formulas. Pick the one that has everything that you want. Actually, everything in that you know, except for that one missing variable. Again, pause it, see if you get it, and we'll go through it together in just a second. Okay, what you should have picked, d equals VIT plus 1/2 a t squared. So we have 12 meters equals 0 meters per second, 4 seconds, plus 1/2 a 4 seconds squared. All I did again, take my numbers, plug them into the formula. 12 is 12, carry that down. 0 times 4 is 0. 1/2 times a times 4 squared. Start with the exponents, right? Remember PEMDAS, parentheses, exponents, multiplication, blah, blah, blah. 4 squared is 16. 16 times 1/2 is 8. 8 times a, that's 8a. So what we have left at the end is 12 equals 8a. Divide by 8 to get a alone. 12 over 8, let's see, you could break that down to what? 3 over 2. So 3 over 2 we know is 1.5. So 1.5 meters per second squared equals a. Again, notice what I did. Write out the formula, plug the numbers in with units, final answer with units. Do it exactly like that, and I'll be very happy. Okay, so that's that page. If you have any questions about this page, let me know. Right? If you need anything, again, just write a comment to me. I'll do my best to get back to you guys as soon as possible. I'll get back to you, but I'll do my best to do it quickly. Good luck.